Good morning. Happy Tuesday. Okay, so we're kind of cruising along here. You might not remember, but at the end of last week, we found a way to actually calculate the mean and the median by hand. Okay, so what we're going to do today is pretty simple. It's just one page of notes. It's just talking about both of these and how they're affected based on the data, right? That we end up graphing and describing and all of those types of things. So again, right, mean and median are both measures of center. Okay, and so it's important that when we discuss these things, you're understanding that these are ways to kind of report the middle, right? The median is more of the middle than the mean, depending on the shape. But we're going to talk about how they both get affected due to the shape of the graph. Okay, so it talks here. It says the mean and median of a roughly symmetric distribution are close together. They are exactly the same if the distribution is exactly symmetric. Now, look, in statistics, we know that things aren't exact. Okay, so it's very rare that it's exactly symmetric. But what it's saying is that if you have a roughly symmetric graph, like we talked about, the mean and the median would be really, really close to the same, and they'd be right in the middle. Okay, but what happens as we end up with, skewed graphs? Right? We have skewed right, the tail goes to the right, and we have skewed left. Well, that's kind of what we're going to talk about here. Okay, so the mean and median will not be the same if we have skewed graphs. Okay, it says here that if it is skewed, the mean will be pulled away from the median towards the tail. Okay, so the mean, right, will go towards the tail. And so on this graph here, again, symmetric, they're pretty much the same. On this graph, the mean might be right here, and the median would be a little bit to the left. So the mean is getting pulled towards the tail. Again, here, maybe this would be the mean, and right there would be the median. Okay, so again, the mean will be pulled towards the tail of a graph. And that's just something that you've got to know. They, easy multiple choice questions, stuff like that, they will ask about it. Okay. All right, so let's go through these 5 questions here. And let's talk about the difference between X bar and mu. So statistics, gets ugly because of all the notation, and these two things are definitely different. X bar is the mean of a sample. Okay, and mu is the mean of a population. Okay, and so let me kind of give you some context here. So let's talk about, Grossmont. Okay, so Grossmont High School has a particular number of kids. And if we went into the system and took every single GPA of every foothiller currently enrolled, and we got the average, that would be the mean of the population. So the population would be the entire high school. Okay, but what if we didn't have time to do that? If we didn't have time, we could go sample. And again, I've talked about, there's a whole chapter about this, but if you just go take a sample, right? Maybe you ask 100 freshmen, 100 sophomores, 100 juniors, and 100 seniors, their GPA, and you find the average, that would be X bar, right? Because it's taken from a sample, not the population. Okay. All right. So then what's up with this word resistant? So what is a resistant measure? So a resistant measure is something that is not affected by large or extreme values. Okay, so a resistant measure is something that is not affected by large extreme values. Okay, and so what does that mean? So let me give you a little example. So let's say we have the numbers 1, 2, 4, 7, and 12. Okay, simple. We've got 1, 2, 3, 4, 5 numbers. If you guys wanted to find the average, okay, we'll assume that this is a sample, and so sample would be X bar. all we would do is say 1 plus 2 plus 4 plus 7 plus 12 divided by 5. 1 plus 2 plus 4, 7, and 12. 4, 7, and 12. And then divide that by 5. And we would get our average is 5.2. Okay. What about the median? The median of this small set of data would be the number that's right in the middle, right? It would be equal to 4. Okay. Well, what happens? Let me leave this here. If I just do something really simple and I still have 5 data points, I'll use the same first 4, 1, 2, 4, 7, and 100. So all that's changed, right, is that this value of 12 now went up to 100. To find x bar, we would do 1 plus 2 plus 4 plus 7 plus 100 and divide that by 5. And so if I go select that and change it to 100 and then divide it by 5, my mean is now 22.8. Well, what's the median? The median is still the number that's right in the middle that has 2 to the right of it and 2 to the left. So the median is still 4. Okay, so this is a prime example of a resistant measure. So this, look at the median. This is resistant. It's resistant because I changed this value to an extreme value, right, compared to the other ones, and the median did not change, right? The median tells you that there are 50% of the data points above 4 and 50% of the data points below 4. But look what happened to the mean. This is not resistant. Okay? And again, you could think about resistant like I'm resistant to change, right? So I'm not going to change by extreme values. Not resistant to change means this is definitely going to affect what happens to the mean. Okay? All right, so can you estimate the mean of a histogram or a dot plot? Yes. And I'm going to say think of the balance point. Okay? What does that mean? Balance point. Well, we talked about it on my little graph. So if you have a dot plot and your dot plot looks like that, clearly this data would be skewed to the right. The balance point, right? Balance point is literally saying, look, if that was a solid piece of mass and I was trying to balance it on the tip of my pen, right? That's how I would balance it. Okay, and the balance point would be the mean. Okay, and you would know, right, if that's the mean, that the median would be to the left of it because the mean gets pulled towards a tail. Okay, so this goes back, right? We've already talked about these last two, but we'll reiterate. Is the median a resistant measure? Yes. Large values, large or extreme values do not change the median. Okay. And then just to sum it up again, how does the shape affect the relationship between the mean and the median? Since I did this on a separate little piece of paper here, I'll put it in the notes so that you use this on a test. So if you have roughly symmetric, the mean and the median are right in the center. Okay. If you have right skewed data, your mean is going to be pulled towards the tail. And so your mean value would be higher than the median. And then if you had a left skewed, again, your mean would be to the left of the median. Okay, the mean gets pulled towards it. So again, right, what if you were told, so data has, let's say, a mean of 42 and a median of 35. What would the shape be? right? So simple question. Look, the mean is 42 and the median is 35. Well, it seems like the mean is bigger than the median. Well, if the mean is bigger than the median, clearly it's getting pulled towards a tail, right? Making this shape skewed right. Okay. And so without seeing data sets, if we look at just the printout of the numbers and stuff, we can kind of get an idea of what that data looks like. In this case, it would be skewed to the right. All right. Take care, you guys.